Hello, ladies and gentlemen. Today we are starting Unit 7, which is the wonderful world of exponents. Sorry, I was trying to jazz it up a little bit. Today's lesson is basically going to be talking about the properties of exponents, and we'll use those properties to simplify expressions. We talked about a lot of this when we did rational expressions, but we're actually not going to be doing exactly rational expressions. They're going to be monomials and sometimes some binomials, but for the most part, it's going to be monomials that we're going to be multiplying or dividing and everything else, and we have to do something special with the exponents. We kind of hinted at this when we did a little bit when we did polynomials as well as when we did rational, but we're really going to focus specifically on exponents. So there are 6 rules we're going to talk about first, and then I'm going to do a couple of examples and go from there. The first rule we're going to talk about is called the product rule. The product rule states we have a to the m power times a to the n power. Now, since we have the same bases or the same numbers, in this case variables, a, what we do is when we multiply 2 variables with exponents, we actually add the exponent. So this is going to be a, and then whatever m is plus whatever n is, and that will be our final answer. Now, all this can be found in page 1 of your packet. We're basically going to be, it's in the upper left-hand corner, it has the little monkey in there. Again, I didn't choose this icon, but they put a little monkey there. But anyway, we're talking about the left-hand box where it says properties of exponents. So I'm just going back through this. So you don't have to write this stuff down. Basically, just me verbally going through this as though I was in class. We're going to, the ones I'm going to do, the examples I'm going to do, which are on page 1 and 2, I'm going to kind of skip around and pick different examples. But those are the ones I want you to follow along with me and write down. The second rule we're going to talk about is called the power rule. All right, so let's say we have a to the m power, and then there's a little n outside or exponent outside our parentheses. Well, whenever we have a base and we have an exponent, and then we have a set parentheses and another exponent outside, what we now do is we multiply a times n. So that will be our final answer, a m times n. Now, for our purposes, these will be numbers. Occasionally there'll be some variables in, but the majority of the time it's going to be numbers. So if that was like 1 and 2, we say 1 times 2 or 2 times 3, and you'll kind of see this a little bit later on. The third rule we're going to talk about is called, this is more of we call it expanding rule. The first 2 rules we condensed. We made two variables become 1, or for rule number 2, we just took 2 exponents and made them into 1. Here, we're going to have a to the b, a times b to the m power. And so again, this is what we call an expanding one, or where we're going to take it and separate the 2. So what all this means is whenever we have parentheses and we have 2 variables inside, that we're going to raise both of these to the same power. So this becomes a to the m times b to the m. All right, so we're going to come back to this not only in this unit, but also when we get into logarithms, which is our next unit and final unit for this semester. All right, the fourth rule we have is talking about a to the negative m. Now, I hinted at this a little bit when we did rational exponents, but we're going to revisit it. Anytime you have a variable to a negative exponent, you're going to put a 1 on top, and you're going to make a fraction out of it, or a rational expression with a numerator and denominator. And you see what happened. The negative m went on the bottom, and it became a positive m. And that's how it works, guys. And so anytime you have a variable to a negative exponent, whether it's a fraction or a whole number, we're going to put 1 on the top, and then we're going to put the variable with the exponent on the bottom as a positive exponent. Okay, the 5th rule we're going to talk about is called the quotient rule. It basically states that we have a to the m power divided by a to the n power, and we talked about this when we did rational exponents, is we always subtract from top to bottom, so it becomes a m minus n. All right, so that's basically, again, for our purposes, these will be numbers like 4 minus 5, or 6 minus 2, or something like that. And then our last rule we're going to talk about is another expansion rule. We're taking one set of rational expressions and separating it into 2. So this now becomes a to the m over b to the m. Now, because our bases are not the same, because we have a and b, we can't subtract these. I know you might be thinking, hey, Mr. Harper, can't we just subtract them? No, it's just like rule number 3. Because we have a and b, those are not the same bases or same number or variables, so we can't add those. Even though we're expanding them, we can't add them, okay? And so those are the 6 rules we're going to talk about, and again, they will be used in conjunction how to solve problems. So we're going to do a couple of examples. And this, if I was in class, we would do these same examples. So if you go down to the bottom of page 1, again with the monkey, and you follow along with me as I do these examples. I'm not going to do all of them. I'm just going to do a couple of them, and then you're going to do a couple on your own. All right, so let's start with number 1. That's always a good one to start with. We have 2 to the x to the third times x to the second. Now, we can't do anything with the 2 because there's nothing else to multiply at times, but we do have these 2 x's. So remembering that when we multiply in variables, we add the exponents. So we're going to wind up with 2x 3 plus 2. And so 3 plus 2 is just going to be 5. I'm doing this, if I was in class, we would just say this in class, but since I'm doing this, fortunately, virtually, we're basically going to add the exponents. So that's why I'm breaking it down like this. If we were in face-to-face, then I wouldn't be breaking it down like this, but I do want you to see where I'm getting the 5 from and not just putting 2 numbers there. All right, so that's the first one. All right, the next one we're going to do is number 3. All right, number 3, we have 2 to the x times xy times 2x to the fourth times 3x to the third. All right, so again, just like we did before, I'm kind of do it a little down this way. So what we're going to do is we're going to say 2 times 3, which becomes 12, okay? Then we go to our variables. We're going to say x times x to the 4 times x to the 3. Well, remember, there's an invisible 1 right here, so that's going to be 1 plus 4 plus 3, and I'll rewrite it out here. I'll say 1 plus 4 plus 3. And then since we only have one y, I can't multiply it times anything, so I'm just going to bring it down here. All right, and then our final answer will just be adding 1 plus 4 plus 5 plus 3, which gives us 8. So this becomes 12x to the 8y. Now, remember, you always want to have these in alphabetical order, so this is the proper format you need to write these problems in. So make sure you're writing this information as I write it down, and that way you'll see where we're getting it from. All right. Next what we're going to do is number 6. All right. Now this one, we had 2x to the fourth, y to the fifth, and then we have a 2 outside. So what we're going to wind up doing is breaking this up into three different parts, but we're going to keep it together. We're going to say 2 to the second, because we're going to distribute the exponent inside the parentheses. So this becomes x, and then 4 times 2, and y 5 times 2. All right, well, 2 to the second power, or 2 times 2, is 4. 4 times 2, which is our exponents, is going to be x to the 8th, and 5 times 2 is 10, so it becomes y to the 10th. Okay, and that's our final answer for number 6. All right, so far we've done a couple, mainly we've done some power rules, we've done some product rules. Now we need to do some quotient rules. All right, so let's skip to number 8. Number 8, we have negative 2x to the third, 3y to the negative 2. Now, we got a couple different things. Now, you're not going to see one that's on the test, but I did want to work out one just to show you this in person. There's going to be some I'll show you more that you'll see on your quiz and your test. Whenever you have a negative exponent like this, what you want to do is go ahead and flip it, okay? And what I mean by that is we're going to say 3y to the negative second on the top, negative 2x to the third goes on the bottom, and then we're going to change this to a positive 2. And then from there, what we're going to do is we're going to distribute the 2 inside. So, again, I'm going to kind of come down here so I have no space. If I was on the board, I could stretch out. But anyway, so we're going to wind up with 3 to the second, and then y to the negative 2 times 2, and that's going to be over negative 2 to the second, and then x to the third times 2. Well, 3 to the second is just 3 times 3, which is 9. And then y, negative 2 times positive 2 becomes y to the negative fourth. And then over here, negative 2 to the second becomes 4, because negative 2 times negative 2 is positive 4. And then 3 times 2 is x to the 6th. Now, we're almost done, except for the fact that we have this part right here. So what we need to focus on is, because this is a negative 4, remember I told you on the rule we had before, Anytime you have a negative exponent, it goes on the bottom. Now, since the negative 4 is the only thing that's negative, the 9 does not have a negative exponent with it. We're just going to rewrite it as 9 over 4x to the 6, y to the 4th. Now, again, you're not going to see that on your test, but if you're taking the ACT or SAT or ASVAB, you may see a problem like this. So I did want to work that out. All right. We'll do a couple more, and that will be it for this lesson, and I'm going to let you loose and have you do some on your own. And that will be on page 3 of your packet. So you'll be working, well, not page 2 of your packet, I'm sorry. It's page 2 of your packet, sorry. You'll be doing some more on that. All right. So I'm going to do number 9, and number 10, number 9 and 10. All right. So let's go to number 9. Number 9 is another dividing problem. We have 4x to the 4th, and then 2x to the 9th. Now here, this is more simplifying more so than it is that. But let's take care of our numbers first. So again, just like a rational expression, guys, we still have to keep this in lowest terms. Because if you notice, all the other problems were always in lowest terms. Well, 4 divided by 2, our greatest common factor is 2 here. So I'm going to divide both of these by 2 and get positive 2 for that answer and 1 for this answer. So I'm going to come over here and put 2 and 1. All right, remember what I said. We always subtract from top to bottom. So we're going to go 4 minus 9. So I'll just put it up here for right now, but eventually we are going to do something else with it. So 4 minus 9. All right, 4 minus 9 is negative 5. And that's over 1. Now, remember I told you, just like we had before with the previous example, number 8, when we have a negative exponent, we have to bring it to the bottom. So we're going to say 2 over x to the 5th. All right? And that will be it. So that's our final answer. So always make sure that whatever your exponential expression is, that it's in lowest terms, especially if you're dealing with quotients and basically fractions. All right, we got time for one more, and that will be number 10. All right. So for number 10, we're going to have 3y 5x over y 3x, sorry. Let me erase that, sorry. Y 3x. Now here, guys, what we're going to, ladies and gentlemen, I told you we were going to deal with numbers, and that's pretty much what we're going to deal with, but we do have variables, so I do want to take care of that situation. All right, well, we can't do anything with the 3 and the invisible 1, so we're going to put that there because there's no greatest common factor there other than 1, and that won't make any difference. But we are going to make this y, and then we're going to subtract from top to bottom again, and we're going to say 5x minus 3x. And we've done this all the time in Algebra 1, even lower math classes. So 5x minus 3x is 2x, so it becomes 3y to the 2x over 1, which we could just simplify to just 3y to the 2x power. And that's our final answer. Now, again, you won't have one of that on the test or the quiz, but I did want to cover that. All right. Well, guys, I'm going to leave you a worksheet that has these different properties and everything else. So just complete that worksheet, and then when I get back in class, we'll go back over it in person, and they'll be very similar to what you're going to see on your test and your quiz. So thank you for your attention, and I look forward to seeing you guys face to face again. Have a good day. Bye.